In the previous section, we have created an object using the function constructor and extended it to add methods using prototype. Then we refactored the same using new ES6 class syntax and saw under the hood that both are essentially the same thing. In this lesson, let's continue extending our ES5 application with prototypal inheritance by creating an engineer function that will inherit from employee and set up prototype chain for its objects. Then we'll refactor it using ES6 class inheritance, which is a lot more straightforward than ES5 method. Okay, let's remove the logs over here and let's comment out this log. As of now, we are working with function constructor inheritance, and let's remove also these logs and we are good to go. Okay, the goal here is to add a new object engineer who also happens to be an employee. So instead of copying all the properties of employee to engineer, we can just inherit employee inside engineer and gets all of its properties and methods. Inheritance is a basic way how we can extend the functionality and behavior of objects. Okay, as usual, to create an object, we need to create a function constructor that will create an engineer object. So I'm gonna create my engineer function constructor like this using function expression syntax. Function, okay, should be engineer. Okay, let's pass some arguments to it. So I'm gonna pass first name, last name, and field as its arguments. First name and last name are the properties that we would like to inherit from the employee object, and field is its own property. Okay. What we want with engineer object is to inherit all the properties defined in employee function constructor and also the methods defined on its prototype. So we need to somehow figure out how we can forge a link from engineer function to employee so that subsequent objects of engineer gets the properties and methods of employee. We'll break this problem down into two steps. In the first step, we'll inherit only the properties of employee function that's been defined over there inside its body, prepended with this dot. Like this dot first name, this dot last name. These are the data members that we want to inherit inside our engineer function. And in the next step, we'll inherit all the methods that's been defined on its prototype to make available on our engineer's prototype. Okay, we can complete the first step by calling out the employee function constructor with execution context this of engineer. So I'm gonna do employee dot call by passing this of engineer, so that all the properties of employee gets attached to our engineer object. Also, we have to pass the required arguments it's been expecting. So I'm gonna pass first name and last name. Okay, so what I'm doing here is this here in this context refers to the engineer function. And by invoking employee through this of engineer context, I'm initializing the properties of employee on behalf of our engineer function. Okay, let's create our engineer function's own property, which will be field. I'm gonna initialize it to our argument field like this. Okay. Now that our first step has been accomplished, let's create an object of engineer. So we already have an object of employee over here. So let's replace it with new engineer. Let's pass an extra argument it's been expecting. Field, I'm gonna pass it as software. Okay, let's enable this log. Let's save it out and head over to our browser to check the output. And sure enough, there it is. So we get to see the properties of employee function defined inside our engineer object, apart from its own properties. Okay. Next thing that we need to do is to inherit the methods defined on employee prototype to the engineer in its prototype chain. So we need to copy employee.prototype to engineer.prototype to make the methods on it available to our engineer objects. Okay, and for any reason, if we try doing like this, engineer.prototype equal to employee.prototype, then it's a bad practice because it's not going to do copying here. This is simply doing object referencing. Engineer prototype object will now reference employee prototype object. So any further additions or modifications that we do over engineer prototype will also get reflected over employee prototype. In a way, if you do this, there is a good chance that we'll pollute the employee's prototype object. So refrain from this approach. Okay. Here, we need to create a new object with contents of employee prototype object and assign that new object to engineer prototype. How can we do that? We use object.create. So I'm gonna write engineer.prototype equal to object.create, and it expects an argument, and I'm gonna pass employee.prototype. Okay. So object.create is just another way to create objects in JavaScript, which was added a little later to the language. It's going to copy or create duplicate of employee.prototype and return that object, which will be set to engineer.prototype. Okay, let's save it and check our contents on the console. So I'm gonna head out to my browser. I'm just gonna expand this __proto chain. So there inside it, we can get to see our get full name, which is actually a method defined on employee prototype, but it is available on our SAM object now. Okay. I want you to observe one thing over here. Let's comment out this line of code. Let's save it. And let's expand our __ proto property. There inside it, we can get to see a constructor property. Every function in JavaScript gets this special property constructor, which points to the own function itself. And even in our case, this constructor property is been pointing to our engineer function. And if we hover over it, we can get to see the function constructor's definition also. Okay, now let's uncomment this line of code. Let's save it and head back to our browser now and expand our __ proto. Now we can clearly see there is no constructor property available inside my __ proto. Because by adding this line of code, what we are doing is we effectively remove the constructor property defined on its __ proto in the process of resetting our engineer's prototype. So we need to restore it back. To restore it back, I'm gonna do engineer.prototype. I'm gonna get the access to its __ proto, and over it, I'm gonna set its constructor property to engineer function itself. Yeah, now let's save it and head back to our browser and let's expand our __ proto, and now there inside it we can get to see the constructor property again, which is been pointing to the engineer function, and also in its __ proto we can get to see the get full name method, which is been defined on the employee's prototype, but it's been referenced over our SAM object. Okay, with this we have successfully inherited both the data members inside employee and the methods defined on its prototype to our engineer function. And so subsequent objects created from our engineer function can access them. Let's prove it actually. Let's try to access get full name method through our SAM object. So I'm gonna do sam.get full name, and let's save it, head back to our browser, and sure enough we can get to see the full name Sam Williams appeared over here. Awesome, right? Okay. Now that our engineer function constructor has successfully inherited both the properties and methods from employee, let's try to add another method to our engineer prototype in the same way as we did for employee's prototype. Okay, one quick note over here. Make sure you are adding methods to the extended function only after setting its prototype chain, as prototype will get reset with this statement. And all the methods defined on the function's prototype will be vanished if we define them before setting its prototype chain here. Okay, let's just add the new method after setting its prototype chain over here. Okay, and I'm gonna define the new method by name get description. Okay, and it's gonna return me so the full name of the employee plus his field plus and engineer. Okay, and now try to access our new method get description through our SAM object. Okay, save it now, head back to our browser, and sure enough we can get to see the output Sam Williams is software engineer. Okay, I could have explained how the JavaScript prototype chain works in more detail, but that would take us away from the topic of understanding React and preliminary ES6 necessary to write React apps. So I'm just confining to this much about function constructors and how to achieve inheritance using them. And looking at all these code, it feels like there are too many things or too much boilerplate code that we need to set up to just inherit functionality of one function into another, right? And people coming from other programming languages or beginners sometimes find it difficult to make sense of all these code until they understand what is actually happening there. Since there are so many unfamiliar terms like .call over here and prototype, object.create, resetting constructor property, all these things. So to fix that problem actually, we have got a convenient declarative syntax in ES6 to do inheritance. Declarative just means that you worry more about getting your work done, but not about how it works behind the scenes. Okay, let's continue to look at how we can achieve inheritance using our new ES6 class syntax now. Let's move on.